Hey, this is day one of calculus. We are looking at chapter 2, section 1, day 1, and I've split section 1 into 3 different days to kind of make it a little more manageable. So what I've got here is what should be happening is we are looking at the same page of notes. So you have a blank copy in front of you. I have what was a blank copy in front of me. If you've had me as a teacher before, you know that normally when I do notes, we fill them out together. That takes longer, and I think what I'm going to try to do is, I've already gotten mine filled out for the most part, and you can just follow along. Now, I probably will go too fast at some point. I probably won't stop, pause, let you catch up like I do in class. So sometimes we'll finish out a problem and I'll just wait for the slower writers to catch up, give it a chance to sink in. So I might not be doing that in these videos, but you have an advantage. You can just pause the video. You can pause the video and catch up. If you feel yourself starting to get lost, stop writing and just watch and listen and get it. And then you can rewind the video and then you can copy it down. So I think this is going to work really well. I'm not a fan of just having the notes already completed for you, but I think in this video venue, it might be a good thing. All right, so we're going to start with limits. This is what an expression for a limit looks like. You need to kind of know what its pieces are, what it looks like, how to say it, and you have to know that all of these parts are required whenever you write a limit on your paper. So this is what it looks like. We're going to call this the answer that we get to our limit, just capital L for the answer to a limit, okay? This stands for limit. We're doing a limit as x gets close to a number. Now think about your x-axis, your horizontal axis. You've got all these numbers that x could be, and we want to kind of narrow our gaze in toward this particular number. So we're going to do the limit as x approaches this particular number of some function. I like it when my function has a name. We can just use the name right here. So if my function f were to represent some big, huge quadratic or quartic or something really messy, I really wouldn't want to write that over and over and over again right here. So fortunately, we can just call it by name right here. So we can either write the function that we're taking the limit of right here, or we can write its name right here, either one. But we got to put something there. Otherwise, we're doing the limit as x approaches a of who knows what. Just find something and go with it. No, we're going to have a function here, and then our answer goes over there. So to say it, to verbalize it, hopefully I get to talk to you all this year. We're going to do the limit as x approaches a of f of x. Or you could say the limit of f of x as x approaches a. Either way, but you have to say those words in some order. All right. I need to kind of change your thinking about the word limit. So most of you drive, and you know that when you're driving down the road, you see a speed limit sign. That means that's the maximum speed that you're supposed to drive. Don't go over it. You need to stop thinking that way for this class. A limit is just as x gets close to the number here in question, as x gets close to this number, where are the y's of the function headed? So as x is headed toward here, where are the y's headed? Not what's the cap? What's the maximum it can be? Don't let me go over it. No. Change your way of thinking. As x gets close to this number, where are my y's headed? That's what a limit is. So I've got across kind of the middle of the page here, it looks like three identical pictures, but they're different in slightly different ways. And notice that even in each slightly different picture, the answer to my limit is always the same. It's some value up here on the y-axis called L. Don't care, but the point is the answer is all the same. Now let's take a closer look. So this pink function, I want you to know there are no breaks, there are no gaps, there are no holes. It's just nice, smooth, probably some type of polynomial function, okay? So this tells us kind of focus your eyes in toward this number on the x-axis. So we don't really need to look over here. Let's look over here. Now, find the function. Well, when x is close to this value, my function is way up here. Okay, and you can see that look at all these points on this function. As each point gets closer and closer and closer to having an x-coordinate of a, you can see that these y's are getting smaller. These y's are getting bigger. But at the same time, they're still closing in on whatever that number is right there. They're closing in on some y value. So as x gets close to here, my y's are getting close to here. Do my y's ever attain a value of this? Yeah, I think so. I think there's an actual point right there. A, comma, L. But that's beside the point. I really don't want to know if my y's attain the value. I just want to know, where are they headed? That's all I want to know. Let's look at the second picture. This one is similar, only check this out. This function is defined. There's a hole right here, but it's still defined when x equals a. So when x equals a, I plug a into my function and I get, I don't know, something, not L. I get a value. It's not L, but I don't care. Watch. As x gets close to a, I don't need to know what's happening at a as x gets close to a. So check this out. As x gets close to a, can you see that these y values are getting smaller? These y values are getting bigger, and they're narrowing in, and they're getting closer and closer and closer to some y value. That's what a limit is. Where are the y's headed? It doesn't matter what the answer is at a. It matters what these are getting close to as we get close to a. And on the last one, it's similar to this one, to the middle one, but there is no function value at a. So if I tried to plug a into my function, it would blow up. There is no, something causes the function to blow up when x is a. Don't care. When I'm doing a limit, I don't care what happens at a. I really don't care that there's a hole there. Here's what I care about. What happens as my x's get close to a? Well, my y's are headed lower, lower, lower. Here my y's are headed higher, higher, higher. Still, they're closing in on whatever this value is. So the answer to your limit is where the y's are headed, not necessarily what the y is at that location. Okay, and then a little more detail about limits. We can look at limits strictly from the left, or we can look at limits strictly from the right. So look at this notation. I hope you can see it. It's the limit as x approaches a, but it looks like there's a little minus sign where an exponent might go. So when it's written like this in limit notation, it's the limit as x approaches a from the negative side of a. Or we say from the left. The limit as x approaches a from the left of f of x. What's our answer? So, let's here's how we're gonna like evaluate that problem. We're gonna look where A is, and then move your eyes toward the left of A. So if I move my eyes here, now bring your eyes closer and closer and closer to A. Where is your function going? Where are the y values going? As we move closer to A, what's happening up here? Well, they're getting higher and higher and higher, and they're getting closer and closer and closer to, I don't know, some y value that we'll call L. So just from the left means we're looking this way. Similarly, we've got a right-hand limit. So the limit as x approaches A. Now we've got a little plus sign, so this means from the positive side of A. So I'm going to, in order to evaluate this, I'm going to look where A is. And then my eyes are going to move to the right side of A. And I'm going to bring my eyes back in toward A. And I'm going to see, where's my function headed? Where's my function? Where are my y's going? And that's the answer to my limit. So in each of these three situations, I'll do that one. In each of these three situations, I could do just the limit from the left. So here's A. I'm going to jump to the left of A. As I move closer toward it, look where my y's are headed. How about the limit from the right? Here's A. Jump to the right of it. Now come back in on it. Come back, come back, come back. Where are my y's headed? My y's are headed toward the same value that they were headed from the left. So, in conclusion, we have this little definition down here, and I'll put it in my terms. The limit. See? Not from the left, not from the right. The limit. The limit exists and has this as an answer. If and only if these two things happen. The limit from the left results in the same answer as the limit from the right. If the left-hand side is going toward a number and the right-hand side is headed toward the same number, the limit exists. If the left-hand side is headed toward a number and the right-hand side is headed toward the same number, the limit exists, and we can write the answer for it. All right, let's try a few. Flip over to the back. So this is a piecewise function. It's in two different pieces. We got 4 questions to answer about this graph. And it all involves x close to x equals 1. So first of all, I'm looking for the limit as x approaches 1 from the left. So this is where x is 1. Jump to the left-hand side, find the function. So I'm to the left of 1, the function is right here. Ready? Now, move in toward 1. See what the function's doing? The function's getting higher and higher and higher. Where? As I move toward 1, where are the y's headed? They're headed toward 1 also. Do they ever reach it? No. Okay, that's where they're headed. So the answer to that one is 1. Now let's do from the right. As x approaches 1 from the right, so here's 1, jump to the right of it, find your function, the function's up here, all right? As I move back toward 1, what's happening to my y values? Where are my y values headed? Well, they're the same. They stay the same, stay the same, stay the same, stay the same, stay the same. They are and are headed toward 2. Next question. What is the limit? What is the limit as x approaches 1 of f of x? Here's what you've got to check. Do my left-hand limits and right-hand limits match? No. So for this, we can say, like, there is no answer. Or we're going to say that it does not exist. I'll abbreviate. Does not exist. You can abbreviate too by this little acronym. Just please make sure that this looks like a D, not an O. Does not exist. Okay, that's it with limits. And then this question was thrown in just for fun, kind of just to make you think. What's f of 1? When x is 1, what's the y value? Not that. The y value is 2. And I put it in a different color just to kind of make it so clear to you. The actual function value, where it's colored in at 1, does not matter when we're doing limits. All that matters is check the limit from the left, check the limit from the right, see if they match. Okay, number 2. We're still approaching 1. So the limit as x approaches 1 from the left. So I'm going to jump to the left. I'm approaching 1. It looks like my y values are getting lower and lower and lower, and I don't know, maybe like negative 1.2-ish, something like that. The graph's a little weird. From the right, so here's 1, jump to the right. As x approaches 1, my y's are getting bigger and bigger and bigger, and they're headed toward 1. The limit. The limit. Does the left-hand limit match the right-hand limit? No. So the limit does not exist. And just for fun, when x is 1, what's the y value? X is 1, the y value is 0. Okay. Still looking at 1 again. Limit from the left. My y's are headed toward 1. Limit from the right. My y's are headed toward 1. The limit, they match. And just for fun, the function value, there's not one. Okay, this one's going to be very similar. Limit from the left, as x approaches 1, my y's are approaching 1. Limit from the right, as x approaches 1, my y's are approaching 1. On the left, limit from the right, they match. So this, the limit, has an answer. And just for fun, there's a point at 1 comma, negative 2. This time we're looking around 0. So limit from the left, as x approaches 0, my y's are headed toward 1. Limit from the right, my y's are headed toward 1. They match. So the answer to the limit is 1. And just for fun, there's a point at 0 comma 1. Also, that was the first time on this whole page where everything matched. This was the first time on this whole page where my left-hand limit matched my right-hand limit, which gave me an answer to my limit. And it was filled in there also. We'll come back to this a little bit later, like days later. Okay, and the last one. As x approaches 2 from the left, so here's x equals 2. Looks like there's an asymptote there. So I'm coming toward 2 from the left, And it looks to me like this keeps going. It looks to me like this is the way I interpret it. I'll put it that way. I hope we interpret it the same way. If not, we might have different answers, and that's okay. The graph was really up to our interpretation. So anyway, as x approaches 2, doesn't it look like my y's are getting higher and higher and higher and higher? So as x approaches 2 from the left, where are my y's headed? They're headed toward infinity. Do they ever reach it? No, you can't reach infinity because I can always go a little bit farther than you. Limit from the right. So I'm on the right of 2. I'm working my way back in toward 2. Look where the y's are headed. Negative infinity. Do they match? No. And just for fun, function value at 2, there is none. Okay, that's a wrap for day 1.